Okay, so welcome to the session. Gonna share this on this window down. So what the focus of the session is to provide you basic knowledge on coding, and uh, one of the assignments students usually complete in STEM, not just STEM classes, my engineering classes as well, is to visualize data, to grab data. And I was thinking it would be a great idea for um, teaching students yet another skill, which is to code. So basically, use code to grab the data. So let me go ahead and move on. The sign-in sheet, please go ahead. I'll give you a minute or two. Please go ahead and sign in, very important. So you can be paid for this hour. Also put it in the chat box. So if there's anybody who didn't find it, let me know. I can put it in again. And a few things about me again. I am a teacher at Tulsa High School, teach engineering, and I'm also an Amazon Future Engineer Ambassador. So the main goal of this session again is to walk you through Python programming by using an online compiler that was actually built specifically to have the code ready to generate graphs. So I'm going to walk you through basic code. What do the lines of code mean? How do they work? We're going to look at some examples for most common graphs, how you can modify them, how you can actually use the code that I'm having in the session and then just make some minor changes to it. And finally, I'm going to walk you through the resources that I found and I'm using in the class. And then if we have time, if you're interested, I can also explain a few things about the clubs that I'm running after school. So as I was previously mentioning, coding, it is a way of thinking outside the box. We got to remember that computers are in need of instructions at the basic level. We sometimes assume that if we tell a computer to graph some data, it's going to do it. But the way computers work is simply to break down the data into, or the instructions into very small steps, and then provide all those small steps to the computer. That's the only way it can successfully run the code and then provide us the outcome. So let me just see. And here we go. I'm going to go ahead and put in the chat box real quick, the sign-in sheet. Here we go. Okay. So as I was mentioning before, coding is becoming more and more useful in both STEM and non-STEM jobs. There's going to be some sort of exposure to coding as a customer service, as a project manager, as an artist, right, as a designer, which are basically non-STEM jobs. But as more and more automation and more computer use and computer science use goes into these fields, students who go and become artists and designers and scientists, they will have to have some sort of basic knowledge for coding. And this is one good way of actually enabling that, right? You just trickle down the knowledge that you gain in this session to your students in one or two assignments, and then they can have this basic skill or it can start them off on the scale of coding. They can then take it to the next step in the resources that I'm going to be sharing at the end of the presentation if they're interested. So moving on, again, I was mentioning that coding is really useful. How is coding useful besides learning to code and obviously applying it? Again, it helps you with your critical thinking, problem-solving skills. Obviously, we have to pay attention to detail. Again, even the smallest typo can impede the code from running. It also requires you to be creative to figure out ways on how you can provide these instructions in the lines of code to the computer, so it can then generate the perfect graph in this case. Math skills are also a skill that students will practice in this case. And then finally, I was mentioning that some of my students completed their internships over the summer, and they mentioned that coding for them was a requirement in their STEM internship. So that's another reason why you can infuse some of these coding lessons or coding ideas into your lessons. So the compiler that we're going to be using, it's called the Matplot library compiler. It's an online compiler. It's free to use. And what it does basically, it takes the code that we write into and changes it into machine code, zeros and ones, right? Which is then processed by the cloud, right? Some server on the cloud, and the graph is generated, and then it's sent back to us on the screen. So that's why sometimes you see a lag time that is there because simply the internet is too slow. These programs are easy to compile, so they're not taking up too much time, but this transfer of data through the internet is what makes the compiler a little bit slow. So the first example I have here is basically a line graph, straight line graph. In this case, we're looking at the example of a velocity graph where we have the independent variable, right, the time, and the dependent variable is distance. How do we create a graph like this? So what I'm going to do is I'm going to go ahead and open up the compiling window so we can actually see how we can write a code and then walk you through the lines of code that we're using. Again, my internet is slow, but I went ahead at the time and actually open the window. I can, in the settings here, you can actually change the size of the text. You can have different themes, tab size. So let me see if I can make it a little bit bigger so you can see it better. Here we go. So this is an example that shows up right away once you open the window. I'm going to go ahead and share this link as well in the chat in case you're interested in opening and following along. So this is the link for the compiler. So there's already a few lines of code here present, right, that you can actually run these codes, and it's going to generate, in this case, a sine graph. But what I'm going to do is I'm going to generate the line graph first. So I'm going to start off by walking you through the lines of code. The first two lines of code start with import, and the first line imports the Matplot library. So as I'm mentioning, think about coding as a lesson that you're teaching to your students. And in this lesson, you're looking at quoting the students from one of your books in your library that you have in your class. So how this works is basically you go to the library and then you find a book, right? And then you take the book, open it to a specific page, and then you read from that page. Well, we got to do the same thing when we write code. In this case, for us to be able to use the library, we got to import the library of code. This is like pre-written smaller programs that we can use. And the first library that we're going to use in this code is called matplot library. And then the second one is the NumPy library. Now, in order to make use of them, obviously, we're going to have to tell the computer to use it. And so we don't have to type in all this long name. We're just going to label it as PLT. So the matplot library is going to be PLT from now on, and the NumPy library is going to be NP. So whenever I'm going to make reference to PLT, I'm actually telling the computer, okay, now go to this library and find one program for me, which we're going to be using in the code. Next, we have the X and Y. These are variables, basically space in the brain of the computer, where we're going to be storing our data, which obviously we're going to be using in the code. So in this case, I am going to make some changes here. I would like to have some raw data that students collected in a lab, or they have it in a worksheet. So I'm going to open a square bracket and then just place in the values that some example values. In this case, I'm just going to use 0, 1, 2, and 3, right? So let's say this is going to be these are going to be the values, the numerical values that will go on the x-axis, right? Independent variables students collected in the lab. That's why I labeled this variable as x, right? And then for variable y, which is going to be the values that will go on the y-axis, again, I'm going to open the square bracket. I'm going to put some other values for 5 and 6, for example, and then 6, 7. So we have like 4 and 4. And in this case, what I'm telling the computer to do with these two lines of code is simply, okay, create 2 spaces in your memory and put in the values 0, 1, 2, and 3, and 4, 5, 6, and 7. This is called an array. So basically, you can have the variable store more than one value, an array of values, right? And in this case, since we're doing a lab, there's more than one data point that you collect, right? It has to be an array to store all that information. The next step is going to be to actually go to the library, right? And then call the program or the function, programming they call it function, that we can use to generate this graph. So to do that, we're going to create 2 more variables, fig and ax, and they will basically, I will basically use the matplot library, right, PLT, to call in the subplots function. This is the function that is actually enabling the generation of the graph. So remember, it's an actual program that takes the data in the 2 arrays, in the x and y variables, and then processes them. Okay, so moving on, we're going to actually use the variable ax, right, which contains the subplots function, and then we're going to plot in using this variable, we're going to plot the x and y values, the value stored in the x and y variable. And then at this point, we can actually run the command. The way we run this command is very simple. We just run hit the execute button on the left-hand side. And when we do this, basically the instruction is being sent into the cloud, right? It's being processed. First, it's changed into binary language and then processed and then converted back into an image. And then we should be able to see it on the right-hand side here. Again, my internet's a little bit slow, so it may take a while until we get the processed image. But again, I took the liberty to actually process it ahead of time. I did put in some more information here. So if my internet won't work, then we can actually revert back to this predefined program which I previously wrote. It is a little bit slow, so here we go. We have it. So in this case, if you take a look, we have our first graph generated, right? It's a straight line, it's a line graph. We do have the x and y axis numbered, that we have the scale on it. So what we could do next is we could a little bit add a few more things to this graph in order to make it a little bit more understandable, right? At this point, I can see the line, but I'm not sure what the values represent along the x and the y axis. I don't have a title for the graph. Maybe a grid would be good as well, so I can identify. I can then use it to find a slope or anything like that. So in order to add these things to the graph, we got to basically add more lines of code. So the code to generate the grid is going to be the use of the AX variable, which contains the subplots function, right? And then just type in grid. And then once you do that, then you're actually going to be, once you click on execute, you're actually going to be requiring the compiler to generate these this grid for you. So in this case, now we have the grid. If you see after each of these lines of code, we do have parentheses. Parentheses basically allows us to customize these commands. So for example, for the grid, there's different options you can still add for it to make it more customizable. The other thing we could do is we could add basically the labels, right? So we were gonna have to label, we have to know what's X, what's Y. The command for that is to set the graph, right? Set the AX variable, and then the parameters that will go into this bracket are gonna be the ones that are gonna be shown on the graph. So in order to represent the x-axis, we're gonna have to use the X label command. And then the equal sign is basically going to be the method to input the information into this X label. So in this case, let's label this as the time, right? Usually measured in seconds. And if we execute this, then we should be able to see the label on the bottom. Again, every time I press execute, all this goes into the cloud, right? And then it takes some time until it generates and then comes back. And if you guys notice down here on the bottom, we do have the time label for the x-axis. Now we can do the same thing with the comma separated. The next parameter would be the y label. Again, you would be using the same procedure. In this case, let's call this distance. In meters, and then finally we can have a title for this, and then the title could be I don't know, velocity graph. Typo here, velocity graph. Here we go. So if we run it, then you're going to be able to actually see this, the title of the graph as well, the labels for X and the Y axis. So once this is done, this is basically the final step that students need to take. How do they save this? Well, they just right click and save this. This is an image, right? So the graph, the generated graph, it's automatically an image. So they can just save it, right? And then they can upload it into a Google form or whatever way you have. They can print it out as well. Whatever way you want students to submit the work. So this is one way of, or one type of graph that can be created. if you check in the presentation, I did put in the code as well in the slides, so you can just copy this from now on and then just simply use it in your presentations. So this is available. The next line of code that we're using is basically, or the next type of graph that we're going to be doing is basically the curved plot. In this case, I'm going to be putting an example of the sinus graph. To start all over, all I'm going to do is I'm going to refresh the page. Everything's going to be deleted. So please pay attention. Every time that you refresh the page, you lose everything. So it's not going to be saved. And then I just actually lost everything right now. And then I started off with the previous example I had. And this is actually one of the examples that I have here on the slides as well. If you notice, I will keep the X and Y variables. I will keep the same two libraries that we imported, right? The commands, the code that was pre-written for us. And then what I'm going to do here is I'm going to make some changes. If you notice here, we do have, for the X variable, we have the NumPy library that we're using NP, right? NumPy. And then in the NumPy library, we're going to be using the range function. And then the range function will actually be taking 3 parameters. So we can predefine how this graph is going to look like. The first parameter is basically the starting point where you want the graph to start, right? We're drawing a sine graph, so I'm going to start it at 0.25. And then the next parameter is going to be the stop, like where would you like the sine wave to stop? Well, I want to do complete wave, so I'm going to do it 2 pi. Pi, it's actually defined as well in this library, in the NumPy library, as pi, right? The pi. That's why you notice this as np.pi. So basically, I'm using the pi command from the NumPy library to access the pi. Next, the last parameter that we put in is the steps. So this basically defines how smooth the transition is going to be in the curve. If you choose bigger steps, if we look at it, you can actually see the lines that make up the curve. And if you choose smaller steps, then those lines that make up the curve are going to be much smaller. So it's going to be basically a smooth transition between the lines. It's going to show more like a curve, not like a curve made out of longer lines. So I'll leave that as is. For the Y variable, I'm going to leave the sine function to be graphed. And then what sine is going to be graphed is going to be basically the X variable that we're going to be graphing. So what I'm going to do next, I'm actually going to be able to run this as is, but I will have to add the previous lines of code, which I already did in the previous program, right? So FIG, AX, and then PLT dot subplots, and then I'm going to go ahead and plot. I'm going to plot the AX. So I'm going to say AX plot, and then X, comma, Y. So basically, I am plotting again, right, the X and Y variables by using the subplots function from the matplot library. In this case, the X and Y variables are going to be basically the X is going to be the information provided to generate the sine graph. So if I run it, again, give it a minute, it should generate a pretty smooth sine graph. Here we go, we have it. So if you notice the transition, so how the computer generates this curve is basically small lines. small straight lines. If we are to increase this step a little bit more, so if I'm going to increase it to like 0.9 instead of 0.1, then I'm going to increase the length of these lines that generate or create the graph. And if you notice, it is still a sine wave, but it is containing these longer lines that make up this curve, which is very visible. So you can tell your students to have this step value small, 0.1, 0.2 probably is going to work, but anything bigger than that, then it shows a, it doesn't really show the sine wave as a curve, it shows it as a combination of straight lines. Now, what else we can add? We can obviously do the same thing as we did before. So we can add the grid, right? So AX grid. And if we run it, you're going to be able to see that. And then we can also add the same labels, right? So we can set the X label. X is usually the independent variable, usually is time, right? So you can have that time. You can set the Y label. If this is a lab data that you did in the electricity chapter, right? You can then think about this as a changing voltage, right? So you can call it voltage if you want to. So voltage, and I'm not sure what you're measuring voltage in, millivolts. And then finally, you can add the title. This could be basically a time versus millivolts, or time versus voltage graph. So if you run it, then you should have the labels ready, right? And you should be able to actually see the labels for the X and Y axis, and also the title of the graph. So here we go. We're done with the second type of graph. Again, you can generate curves as well as straight lines. Again, I'm going to be covering two more, and it's very, very simple how you go through. We're just going to be using the same procedure. So the next graph we're going to look at would be the bar graph. In this case, I'm just going to generate 2 bars, but you can generate more than 2, 3, 4, as many bars as you have. Again, this is useful for data analysis, especially to see variations, right, in all of those bars. So I'm going to go ahead and, again, reload the page. I'm going to lose everything. Remember that when you reload the page, you do lose the previous code. And in this case, since we're using a bar graph, I am going to replace the X and Y variables with names that are a little bit more relevant. Again, you can have any kind of name for them. So in this case, I'm going to call the first variable as a bar, right? It's going to be using the bar, making the bar graph. In this case, I'm going to be making basically 2 bars. So I'm going to call those bar 1. You can, again, label them based on your data, and then bar 2. The second variable I'm going to make is going to be the bar value. So in this case, what I'm adding is basically, in the first variable, I have created basically the space in the memory, right, to store the information for these 2 bars. In the second variable I'm creating, I'm actually putting in the numerical values in these bars. So how much is going to be bar 1? How much is going to be bar 2? So that's what I'm doing here. So I don't know, 20 and 40, for example. And then I'm actually ready to move on to the next line of code, which is the same as we did before. So we're going to generate or create the fig and the AX variable. The AX variable is going to contain the subplot PLT from the PLT library. So again, this is the line of code that generates the graph. And in this case, what we're going to do is we're going to use this AX variable, right? and we're just gonna change it this time. So we're not gonna use plot to generate a line or a curve. In this case, we're gonna be generating a bar. So we're gonna use ax.bar graph, right? It's bar. And then what we're gonna use next here is we're gonna put in the parameters for this bar graph, which first is gonna be what kind of variable contains the information for this graph. So it's going to be the bar variable contains the name of these bars, right? And also the bar value is going to be the variable that contains the numerical value of these bars. So basically how high they're going to be. This is basically enough for us to be able to actually run it. So we can then run or click execute, and then we should be able to see some sort of basic bar graph. Now there's more to it, right? We can do the same thing as we did before. We can add the grid to it. We can add the labels. We can add the title. We can actually add a legend to this as well. So how do we do all that? Well, obviously, we're going to use the same code we used before. So for the grid, we're just going to use AX grid. And then if I execute this, we should be able to see the grid. We can actually, in this case, we can actually create, change the color of these bars. And to do that, we do have to define the color ahead of time. So I'm going to go back up where I made the two variables, and I'm going to make another one called bar color. And in this case, I'm going to define the color of these two bars. Again, how you're making the array, the computer automatically knows that if you type in the first color, then that's going to be for the first bar. The second color is for the second bar. So this is, by definition, it's the computer knows this. So the command to do a changing color is called tab. And then here you can type in the color of the first bar, and then the color of the second bar will go in the second set of instructions here, which is going to be, again, tab, and then you can make it any color, orange, for example. Orange. And then once we have the second variable, what we can do is we can actually go back to the bar command, AX bar command, and then put in the additional instruction, right, for the color, which is going to be stored in the bar color variable. So if we run it, then basically we're going to be able to change the color of these bars. So now we have them green and orange. Previously we had them blue. Finally, if we want to label these bars as well, we can use the label command or the label parameter. And in this case, I'm just going to use the name that we created in the bar variable. So on the bottom, it actually shows bar 1 and bar 2. That's how we named them, bar 1 and bar 2. What we could do next is we could actually use the label command again, or the set command, to label the X and Y axis, right, as we did before. We're going to label the X axis. We don't really need to label it because we already have it, right? The bar 1, bar 2, it's X. But we're going to label the Y axis, so Y label. And this one could be labeled as, I'm not sure what this measuring. Let's think about height, right? So you can say height in meters. So if we run a code, execute, right, then we should have the Y-axis labeled as height, as you notice here. Now the next step is to have basically a title for this graph. You could call it bar graph, for example. And if you run this, then you should have a title for your graph as well, bar graph. Finally, the final step is to provide basically a legend, which could be a description of the value on the bars, right? So you could use AX again, and then you type in legend. And in here, you can put in the title for it, title for the legend, and call it legend. Once you do, again, you should see a small window, right? That's going to show up, and it's going to have the legend for this graph. Finally, what we will need to do next is the bar values. So we can actually add the 20 and the 40 to each bar, so it can be shown on the bar itself. So whenever you checking your student work, you can actually see the numbers on it. And the command to do that, again, we're going to be using the matplot library again. So the AX variable makes use of the subplots function, and then in this case we're going to use bar label. And the bar label command has two parameters, or more than two, but we're going to be using two parameters. And the first parameter is going to be basically asking where we do have the information about the bars, and that was actually the line of code here where we use the X bar. So I'm going to actually make another variable here called P. Instead of typing all this in, I'm just going to use P here. And then the second parameter is going to ask about the location where we want to put these values in. So I'm going to put the label type to be in the center. So in this case, if we run the code, you should actually see the values of each bar at the center of the bar. You can change this value to top or bottom, so you can have the numbers on the top or on the bottom. And that's it. So this was the third one, the third graph. And then finally, the last one, I'm going to refresh it so we can see it better. I'm going to go back to the last one. And the last one is basically a pie chart. Very, very simple and same procedure as we used before. So the computer is a little bit slow. The internet is actually a little bit slow. Just give it a minute. And I believe we still have a few minutes left. So I'm going to go actually and open this window here. Already pre-built it. So we go a little bit faster as my internet is not working at the moment really well. So in this case, again, we do use the same libraries. I do make two new variables. In this case, I call them slices. So the label for the slices, I call them slice 1 and slice 2. And then the value is 40 and 60. So when I'm thinking about these values, I'm always thinking about, well, you kind of want to, you don't have to, but you kind of want to think about 100% in this case. So these values should add up to 100%. So you have that nicely represented and proportionally represented pie chart. So 40 plus 60, it's 100, right? Finally, I do use the same command as before. So I'm going to use the subplots, right, function. And in this case, the only new thing we're using is going to be the pie command, so ax.py. And then I'm just going to use the two variables again as I use them in the bar graph. So the slice values and then the slice label as the label for these slices. The auto percent is basically the function can add the percentage of these slices on the graph so you can actually see it. And the instruction here is basically telling the computer how many decimal places you want to have in this visual representation of the values. And that's it. So these were the four graphs. Just remember that students can actually save this anytime, so they can have this save, right-click, and then save image as, and then they can submit this work to you. So here I do have one example. I'm going to go through this, and I have some more examples as well. I'm going to go through this, the sandbox session, if you're interested. So I'm going to move on real quick with some of these resources. So I was mentioning about internships. I encourage my students to participate. It's really, really useful in their college applications, and also in their experience, right? So they're actually going to be working in the field in which they want to be finding a job in after they graduate from college. So internships are a really, really good way to do that. This is one example. It's called the CAP internship. It is through the Naval Postgraduate School here in Monterey. This option, but there is like other places where you can go and have your internship over the summer. And this is actually a paid internship. So students are actually being paid. In this case, it's $4,000 for the summer. So they're going to be working for the 2 months in the summer with engineers in this case, and they're going to be paid as well. The compiler I'm using is called the online Matplotlib compiler, so you can feel free to click on this link. I'm going to be sharing my presentation as well. I'm going to send you a link in a minute. And then there's more resources you can have students use if they like coding in the future. So some of them I use in class, for example, Tinkercad. This is actually a platform where you can do 3D modeling, you can do build circuits, electrical circuits, you can actually program the components on these electrical circuits. You have like microcontrollers you can program and so on. This is free. You do need to have a Google account to sign in. Project Hub Arduino, like more like hands-on programming here where you program like actually Arduino boards and you can connect those to sensors and motors and so on. MIT, Scratch, right? It's another option. If students want to start learning coding, it's a really good resource. Hour of Code from CodeHS. This is basically smaller projects, right? Where it takes you a little bit less time to spend on the coding project. And then you have the Earsketch. Earsketch is basically writing code to make music. This is awesome. I do use it in my class. Students like it. Furia Labs, it's another one. They actually, this one does require a license. They use these robots which you program to do different tasks. The robots have motors and sensors and everything. So it's really, really hands-on assignments. Finally, the Amazon Future Engineer. It's actually like a comprehensive website. So they don't just have curriculum. They give you the option to do like career tours, virtual guest speakers. So you can actually speak with engineers and see what they're doing on their job, what colleges they went to, how did they went to college, so all their experiences. There's a teacher fellowship, there's a scholarship for students, and internship for students as well they can apply to. And then finally, the Amazon AWS Academy, Web Services, Amazon Web Services, Cloud Services Academy, where students can actually learn to be managers, cloud managers, Amazon Web Services cloud managers. Okay, so I'm going to go ahead and stop here. I think I'm 1 minute short, so if you have any questions, please let me know. I'm going to go over the robotics club information as well in the sandbox session. So I'll go ahead and stop here. Let me stop the presentation, and then I'll go ahead and share my slides as well. So I can, so you guys can take a look at it. If you're interested in any of this, feel free to click on the links. Okay, so finally, there's one thing that I'm going to ask you is to complete the feedback. So I'm going to be go ahead and putting this link in the chat box. So feedback link. So please take a minute and complete the feedback. And then if you're interested, back in the sandbox, I'm going to be back here at 11 o'clock. I'm going to stay here. Actually, I'm not going to exit. And if you would like to remain here, feel free to do so. If you'd like to exit and then come back, that's fine as well. Whichever you like to do. So 10-minute break, and then I'll start the sandbox at 11 o'clock.
Mr. Incze, the feedback form is for your presentation, and after the sandbox, do we fill out the same form, or?
I assume yes. So we did receive only one form for the feedback.
Okay.
So it's the same form, I believe. Yeah.
Okay, so I'm gonna fill it out after the sandbox then, because yesterday they had us do it after the sandbox. Is that okay?
Yeah, that's fine.
They told us not to fill it out early.
Oh, okay.
We'll see you shortly.
Okay, yeah, thank you. So yeah, let's keep the feedback then until after the sandbox.
Okay, perfect.
Thank you. Yep. Okay, so I'll take a break. Let's take a break, 10 minutes, and then I'll see you back here at 11.